Scariest problem ever leads us to our next one. That's not a geometric series. But all the time, students sometimes think it is. That's not geometric. Let's make it a not geometric. Does everyone see the monomial in the numerator? That's not geometric. If you mix a monomial with an exponential, that thing is not geometric. Geometric's only exponential. So we need a new test. Well, this is one of the coolest tests of all. It's called the test for divergence. If the limit of the sequence is not equal to 0 or does not exist, then this series must just diverge. I do want to point out this test doesn't have a test for convergence. It just has one flat out test, but it's so cool it will tell us whether or not that series is divergent. If the limit of the, notice that doesn't have a summation here, the sequence. Where's the sequence? That's the sequence. Everyone see that? So make a note, that's the sequence. If the limit of that sequence right there is not equal to 0, then the series is divergent. I can't give you that problem yet. I just want to give you an example. That's not geometric, right? But I would like to give you this one. How about that? Determine whether that series is convergent or divergent. Right now, you and I only know two tests. We know the geometric series test and the test for divergence. That's all we got right now. Joe? Well, is that geometric? No. So can I use GST? No. This is not geometric. Don't let that end down here and think, okay, monomial with exponential, it's not geometric. So all we're left with is maybe trying this little test here. So I'm going to hide this. And can you think about that sequence and what we talked about earlier? What if you got an exponential over a monomial and you're taking the limit as n towards infinity? What's the limit of that sequence without the series? Infinity. Infinity. Does everyone agree? So look, when I write my notes here, I'm like, the limit as n approaches infinity, I'm not putting that series symbol, of just this, the sequence is infinity. Exponential over monomial, right? So what do I know about this series? This diverges by the test for divergence. Can I justify it? In counter, I'll just write this. Because the test for divergence says as long as the limit is not equal to a what? 0 or just does not exist. So when can I can't use this test if the limit was 0. That's why we couldn't use my previous problem I had up there. I took it all. You go, we'll cover that tomorrow. But we do that one on Thursday. Cool. Hey, let me give you another one. This is a great one. This is a quick one. Try this one, everyone. I'm taking something from earlier today. 5n plus 2 over n minus plus 1. Just something from earlier today. Is this geometric? Oh, heck no. This is not a geometric series, right? Geometric series, we'd have that exponential expression, right? And that's all we'd have. What do you know about the limit of that sequence, though? In this case, when the limit as n approached infinity of the 3 to the nth over n, that's a sequence, so it diverges by TFD. Well, what's going on with this guy? What's the limit as n approaches infinity? Let's just call this a sub n. Notice I'm just putting that. All this in the parentheses, let's just call this a sub n. All that right there, that's the sequence. Remember the notation for a sequence? See the notation for sequence, a sub n? No series. What's the limit as n approaches infinity of that? So let me hide this. Hide! What do you think is going on with that? Do you remember what happened with that thing? That's a rational expression. What's that heading towards? That's heading towards 5. See the equal powers? Cool, good eye. What's this magnet do though? It's oscillating, it's alternating between a 5 and a negative 5. Is the limit not equal to 0? Yes. So what do we say about this series? This series is divergent by what test? And you're going to totally abbreviate. Test for divergence. Unless you want to write out test for divergence on the test. But you always have to justify, so Connor, this is what I wrote. the limit as n approaches infinity of a sub n does not exist.
What is that one going to 5?
This is going to 5, but this is making it go to what? Now, I'm going to do something. I'm going to give you another one problem. This one's going towards 5 and negative 5, 5 and negative 5, so it doesn't exist. And then I'll get your question, Katie. Armando, I'm going to take this negative 1 to the n plus 1 off, okay? How about that problem? What if you see that on the test? Isn't it the same answer? Because what's the limit?
5.
That's a 5. This test is rock and roll awesome. As long as that limit is not what? See, when it's 0, you got to use another test. You follow me? So you might look at this one first thing. Like, can I use test for divergence? It's one of my favorite tests of all of them. And that's why I wanted to make sure, you know, ooh, I got to make sure I know all the tests. Don't worry, there's not like there's 20 of them. What do we got here? We got like 1, 2, 3, 4, 5, 6, or 7. Oh, great, Kate.
So should we memorize all these tests for the
Absolutely.
test
Be really familiar with them and just kind of study them. And I wanted to show you one before you packed up. One of the neatest series of all. And we can justify this tomorrow with the integral test. Do you all remember those improper integrals? Oh, you're going to find the integral test so easy because that's all we do. If the integral converges, the series converges. When we look at the integral, something like this. But, last problem. Oh, can you see that series right there? There's a name for that. It's called the Harmonic Series. Now, what might help you out is, does anybody recall this integral? It might help you understand the answer to this thing. Do you remember what happened with that, whether or not this diverged or so? This diverges. So guess what goes on with this series right here? This diverges. But I want to point out, it's called the Harmonic Series. But there is a relationship here, and we're going to talk about an integral test tomorrow. And your integral test, you just look at that integral, and you go back and do those improper integrals. But do you recall this diverges? So I just want you to recognize it's got a name to it. It's called the Harmonic Series because the way you add the numbers up. So, what about this then? Because there's one like this in your notes. I didn't want this to bug you on the test. Look. What about that? Well, this is called a, ready? This is a constant multiple of a harmonic series. So guess what goes on with this?
Can you do the same with putting the 30 in front of the sigma?
You just put the 30 in front of this. What happens when you multiply a 30 to some series that's divergent? What's going to happen? It diverges. It's called a harmonic series, but this is called a constant multiple of harmonic series. But all we have to do, Connor, on a test is say this, justify this. You would say, that's a harmonic series with a constant multiple of 30. Diverges. Cool? Everyone have a great day. Super job. You like this stuff?